Now you'll have some questions about piecewise functions, and it will say that you have to find the constant k. So to find k, that's going to make the function to be continuous. So if you'll notice in each one of these, there's a value of k that you have to figure out what that is in order for the function to be continuous. Now, just remember, these three conditions, f of c has to exist, the limit from the left and the right have to be the same so that the limit exists, and then those two values, the value has to equal the limit. This still has to be met. So we're going to use this definition to help us figure out what k is. So for example 7, it's on page 72 in your workbook. I'm going to start off the same way. So I'm going to start with that first condition by finding f of 1. And I'm finding f of 1 because that's where the function breaks apart. And f of 1, I'll use the top formula. So f of 1 is 3 times 1 plus 2, which is 5. Okay? Then the second condition deals with checking the left and the right-hand limit. So the left limit, let's see, limit as x approaches 1 from the left. I'll use the top formula because those values approach 1 from the left side according to that symbol of f of x is equal to 3 times 1 plus 2, which is 5. Okay, so far so good, 5 and 5. Now let's check the limit as x approaches 1 from the right of f of x. I'll use the bottom formula because those are values on the right side of 1. So 2 times k minus x, but instead of x, I'm substituting in 1. Ooh, that's an expression. That's not a number. So in order for the limit to exist and in order for the value to be the same as the limit, I need the right side limit and the left side limit to be the same. So I need 5 to be the same as 2k minus 1. So setting that up is going to let me solve for what k is. So add 1 to both sides, we get 6 equals 2k. And so then k is equal to 3. Now, if k is equal to 3, my function is now 2 times 3, which is 6. Hold on, let me get it better clear. Now this function is 6 minus x, and so that would mean the limit would be 6 minus 1, which would be 5. So the limit from the right would be 5, the limit from the left would be 5, the value would be 5, and then the function would be continuous at x equals 1. So I need k to be 3 for that to happen. Let's look at this second one. Let's first of all find f of 2, because again, 2 is where the function breaks apart. So I'll use the top formula. F of 2 is k times 2 squared, which is 4k. Okay, then I'll need to find the limit. So the second part, the limit as x approaches 2 from the left of f of x. I'm going to take the left side again, substitute in 2 for x. 2 squared is 4, so 4k. Now let's find the limit from the right. Limit as x approaches 2 from the right of f of x. Use the second formula and substitute in 2 for x. I'll get 2k minus 6. Now, in order for the limit to exist, I need these two to be the same. So we need 4k to equal 2k minus 6. So then I'll solve for k, subtract 2k on both sides. We get 2k equals negative 6. Divide by 2 on both sides. K equals negative 3. So if k is negative 3, then the limit will be the same as the value, and the whole function will be continuous at x equals 2. Let me show you one like you'll have in Delta Math. So Delta Math will be very similar. It's copied and pasted from Delta Math. So let's try this one. I need to figure out, is this function going to be continuous, or I want it to be continuous at x equals 2. So first of all, I need to find f of 2. So So I'll do that with the top formula, substitute in 2 for the x. I'll get 2k minus 12. That second condition, I need to check the limit from the left. So limit as x approaches 2 from the left of f of x. Now be careful. This symbol, the less than symbol, tells me the values that approach 2 from the left. So that's negative 3x plus 4. And I'm going to substitute in 2 for x. So negative 3 times 2 is negative 6. And negative 6 plus 4 is negative 2. So the limit as x approaches 2 from the left is negative 2. Now I need the limit from the right. So the limit as x approaches 2 from the right of f of x is where I'll use my top formula because these values approach 2 from the right. So I'll use this formula. It's k times x, but we're substituting in 2 for x, so 2k minus 12. Now for the limit to exist, we need this value and this value. We need these two values to be the same. So we need 2k minus 12 to be equal to negative 2. So here's an equation I'll solve. So 2k, add 12 to both sides, is positive 10. I'm getting that k needs to be 5 in order for this function to be continuous. All right, so good luck on your assignment. If you need anything, you can click the Zoom link during class or schedule a help session. Have a great day, and I'll see you guys later.